Here are some examples of the specific types of thermal expansion. The first example is in linear expansion, and the problem goes like this. The Humber Bridge in England has the world's longest single span, 1,410 meters. Calculate the change in length of the steel deck of the span when the temperature increases from 10 degrees Celsius to 28 degrees Celsius. Solution. So, delta L is equal to alpha dot L naught dot delta T. So, the given values are L naught, which is 1,410 meters, then delta T, which is 18 degrees Celsius, since 28 degrees Celsius minus 10 degrees Celsius, so delta T is 18 degrees Celsius. Then the alpha for steel is 1.2 times 10 to the power of negative 5 Celsius degree inverse. So, input all the given values and then we will come up to the change in length, which is 0.30 meter. So, therefore, the length increases when the temperature increases. Another example of linear expansion is here. A wire that is 1.50 meter long at 20 degrees Celsius is found to increase in length by 1.90 centimeter when warmed to 420 degrees Celsius. So calculate its coefficient of linear expansion for this temperature change. So, the solution is the given values are the original length, which is 1.50 meter, then the change of length, which is 1.90 centimeter, and our delta T is equal to 400 degrees Celsius, since 420 degrees Celsius minus 20 degrees Celsius is equal to 420. So, using the formula of delta L is equal to alpha L naught delta T, we can now manipulate this formula and come up with the equation of alpha, which is alpha is equal to delta L over L naught delta T. So, substituting all the given values, like delta L is 1.90 times 10 to the power of negative 2 meter. So, centimeter converted into meter. Then, over our original length is 1.50 meter and our delta T is 400 degrees Celsius. So, as a result, our alpha is equal to 3.2 times 10 to the power of negative 5 Celsius degrees inverse. Our next example is in area expansion. Then the problem goes like this. Find the thermal coefficient of material whose area is 2 meters squared. The change of area or the delta A is 2.2 meters squared, and the change of temperature or delta T is 85 Kelvin. So, we will now find out what is the alpha. Solution. The given values are area, which is 2 meters squared, the change of area, which is 2.2 meters squared, and the change in temperature, which is 85 Kelvin. So, from the formula of area expansion, which is delta A is equal to 2 alpha A naught delta T. So, manipulating that equation, we will now come up with the equation of alpha is equal to 1 over A times delta A over delta T, which we can find what is the alpha. So, substituting all the given values, which is 1 over 2 meters squared times 2.2 meters squared over 85 Kelvin. So, as a result, our alpha is equal to 0.013 times 10 to the power of negative 8 Celsius degrees inverse. Another example for area expansion goes like this. A circular sheet of aluminum is 50 centimeter in diameter at 15 degrees Celsius. Then the question is, by how much does the area of one side of the sheet change when the temperature increases at 27.5 degrees Celsius? So, the solution for this problem is here. The given values are the diameter, which is 55 centimeter. Then the alpha for aluminum is 2.4 times 10 to the power of negative 5 Celsius degrees inverse. Then our delta T is equal to 12.5 degrees Celsius. Why? Because 27.5 degrees Celsius minus 15 is equal to 12.5 degrees Celsius. So, the formula for area expansion is delta A is equal to 2 alpha A naught delta T. So, substituting all the given values, which is our alpha is 2.4 times 10 to the power of negative 5 Celsius degrees inverse. Then, our A naught or our original area is pi r squared. So, the diameter, you will convert that into meter, then use the formula of pi r squared. So, pi times 0.275 meter squared times 12.5 degrees Celsius, which is the delta T. So, as a result, our delta A or change in area is equal to 1.4 times 10 to the power of negative 4 meters squared. Our last example is in volume expansion. And the problem goes like this. A steel tank is completely filled with 2.80 meter cube of ethanol when both the tank and the ethanol are at 32 degrees Celsius. When the tank and its contents have cooled to 18 degrees Celsius, what additional volume of ethanol can be put in the tank? So now, we will find out what is the additional volume of ethanol that can be put in the tank. Solution. The given values are the beta of ethanol, which is 75 times 10 to the power of 5 Celsius degrees inverse. Then, the beta of tank, which is 3.6 times 10 to the power of negative 5 Celsius degrees inverse. And the original volume is 2.80 meter cube, and its delta T is equal to negative 14 degrees Celsius. Why negative? It is because its final temperature is lesser than its initial temperature. So 18 degrees Celsius minus 32 degrees Celsius are equal to negative 14 degrees Celsius. So the formula in finding the additional volume is delta V is equal to beta times V naught times delta T. So first, we will now calculate the delta V of the tank. So the B naught or the beta of the tank is 3.6 times 10 to the power of negative 5 Celsius degrees inverse times its original volume, which is 2.80 meter cube, times its delta T is negative 14 degrees Celsius. So the delta V or the change in volume of the tank is equal to negative 1.41 liter. And now, for the ethanol, delta V of ethanol is equal to negative 29.4 liter. So, calculating the additional volume of the tank, so delta V of the tank minus delta V of the ethanol is equal to delta V total or the additional volume. So, negative 1.41 liter minus negative 29.4 liter is equal to 28 liter. So, the additional volume is equal to 28 liter. Our next example for volume expansion goes like this. A copper cylinder is initially at 20 degrees Celsius. At what temperature will its volume be at 0.150% larger than it is at 20 degrees Celsius? So, solution. The given values are the beta, which is 5.1 times 10 to the power of negative 5 Celsius degrees inverse. Then, the initial temperature of 20 degrees Celsius. Then, the volume, of course, of 0.150%. So, our formula for volume expansion is delta V is equal to beta V naught delta T. So, in order for getting the change in temperature, we will manipulate that formula, and of course, our formula for delta T is equal to delta V over V naught over beta. So, substituting all the given values, which is our delta V over V naught is equal to 0.150 times 10 to the power of negative 2 over 5.1 times 10 to the power of negative 5 Celsius degrees inverse. Then, as a result, our delta T is equal to 29.4 Celsius degrees. Then in the problem, we will find out what is the final temperature. So, in getting the final temperature, we have the initial temperature plus the change in temperature. So, T naught plus delta T is equal to 49.4 degrees Celsius.